Here's another warm-up. Please pause the video and try them out. So I'm going to multiply the top and bottom by the conjugate of the numerator because of that radical. I want to make sure that the denominator will not have an x minus 2, as I cannot do that since the limit's approaching 2. And that would make the denominator equal 0. So let's see what we get. So we're in luck. The top will be x minus 2, which means that the top and bottom are going to cancel. The x minus 2, of course. So when you plug in 2 now, you're going to get 1 over the square root of 1, which is 1, plus 1, which is 1/2. So let's do the second one. As it is right now, we cannot plug in a 4. So what do we do? You guessed it, we factor. So cancel out the x minus 4's on top and bottom. We end up with 1 over 8. That's the beauty about limits, because if this was a traditional function, you would have to say does not exist, because 4 is no longer in the domain, since the denominator was canceling out 4. However, since it's a limit, we don't care about that. Since we're just approaching 4, we're not actually 4. The last one's very easy. It's the easiest of them all. You can simply plug in. So our answer is going to be 2 times, and then whatever 3 power 4 is. That's actually quite easy, because if you know unit circle really well, then you know that 3 pi, if this is the x and y coordinate, it's like the center right there, because this is pi over 2, otherwise known as 2 pi over 4. My 2 looks suspiciously close to a 3. So this would have to be the middle between 2 pi over 4 and 4 pi over 4 would have to be 3 pi over 4. A sign represents the y coordinate. Now, long story short, it's going to be square root of 2 over 2, which ends up being square root of 2. Alrighty, so for this one, we're going to look at this function, this polynomial, degree 3, and find the derivative, which ends up being negative 3x squared minus 6x. And then it says, plot the graph on the same. So, clearly, this bad boy is going to be the actual function, right? F of x. And the reason why I know that is because since it has a degree 3, it hits it on 3 occasions. That kind of gives it away. The red one would have to be the derivative. So let's talk about it real quick. Just a review from the last session. Because we have a minimum, that implies that my derivative must be 0. We have a maximum, that implies my derivative must be 0. So that's how you find the x. I should have done a different color. Let me use yellow. So I was talking about this guy and this guy. Let's not just say, let's just look at the slopes. Since we're looking for the derivative, the function for derivative, we just have to know what the slopes are at any given point. Over here, all of the slopes are negative, which means that my function starts in a negative. And given that the slope here is steeper than it would be, let's say right here, it starts at negative infinity. After the minimum, slopes are positive, so we go above again. But then it reaches 0 once again, which is why it goes back down. And then again, we're going to have negative slopes becoming more and more steep, meaning it's going to go back down to a negative infinity. Let's continue. F of x equals negative x cubed minus 3x squared plus 1. For what values of x is the derivatives positive? What is the graph of f of x doing in these values? I know. You can hardly understand when I'm reading a problem, and also my writing is bad. However, does it matter if you can see it? So, we took the derivative. I factored it also because, as it was asking, for what values of x is the prime positive. So I really care about when x equals 0. So x seems to equal 0 at 0, x equals 0, also seems to equal 0 at negative 2, which means that it's going to be either positive or negative in each region. When x is, let's say, negative 3, we would have a positive here and a negative here, which would overall make this negative. Now, I can also start plugging in numbers between negative 2 and 0, and then numbers that are after 0, but I don't really need to do that because this right here is a degree 1, and that's a degree 1, which means that it's alternating. Plus and then minus. As far as the question, what's the graph doing at these values for the positives, it's increasing because it has a positive slope. So I could human write it down. So f of x or y is increasing in value since the slope is positive, and it needs to have a positive slope because the derivative is positive. For what values of x is f of x decreasing? So for that, you would actually, I guess you can write like a domain little thing. So negative infinity, not including infinity, so that's a parenthesis, and up all the way up to negative 2, and then we're going to bound it together with 0 all the way up to infinity. I already talked about why you don't include infinity and the endpoints, because the derivative requires it's a limit definition for a derivative, and a limit is only valid if it has a negative, if the point is approached by the negative and the positive. And since endpoints are only approached from one side, that limit doesn't exist. It's a definition of limits that you guys probably went over in pre-cal. Alrighty, and this is union. I'm not going to insult your intelligence by explaining that, but this is when the slope is negative. And then, oh, I didn't write it over there. That would be from negative 2, not including negative 2, all the way up to 0. What is the function doing at those points? It's decreasing in value. So let's continue. For what values of x does the derivative equal 0? Another way to ask is, at which points does this function have either a maximum, minimum, or plateau? What feature does a graph of f have at these values? Oh, okay. Well, yeah. Let's find out what the derivative looks like. I have such a bad memory. I can't believe I didn't realize I just did this problem as far as finding the derivative. Anyways, the 0 is, it happens at 0 and negative 2. And what, well, if you go back to the previous one, we remember that in these regions, we had first a negative, then a positive, and then a negative. And if you just think about it, if a graph is decreasing in value, and then suddenly, because of that negative slope, and then suddenly is increasing in value because of that positive slope, then we know that this is a minimum. So at 0, that would be a minimum. Now, when we are increasing in value, but then suddenly decrease in value because of the negative, then that would be a maximum. So at negative 2, that's a maximum. Of course, when you take notes, you're going to make this a lot more pretty than I am, because I'm the teacher and I don't have to be able to do anything pretty, but you're the student and rules apply to you. Alright, if you have another one right here, the derivative is given, find the intervals of increase, decrease, find the maximum and minimums. So, let's discuss this. Over here, the derivative is negative, so between negative infinity to negative 2, that's negative. Then, when we look at this area, we are above the x-axis, which make it a positive. So the whole point is, when you're above the x-axis, you're positive, when you're below, that's negative. So, when is the derivative positive? It's positive at these regions right here, and right here. Let's continue. So, that's when it's going to be increasing. I already talked about what this little symbol means. It means union. It means that you're combining two sets to make one domain. When is the derivative negative? Let's look. Derivative negative and it's underneath the x-axis, so we're talking like right here and like right here. So from negative infinity to negative 2 and from 0 to 3. Let's go ahead and get right there. So now the question is, when is the maximums and minimums? Since, let's go ahead and use a different color. Since we had a negative derivative, right? And then we had a positive derivative, that means that something was decreasing and then increasing. That implies a minimum. And then since we had a positive, let me change color again. Since we had a positive and then we had a derivative, and then we have a negative derivative, that implies that we're going to have an increase and a decrease. That's a maximum. Then we again go from a, let's change color one more time, from a negative to a positive derivative. That means something was decreasing and then it was increasing again. So that's again a minimum. So we have a minimum at this point and this point, and we have a maximum at, let's use yellow, this point. Hence, what's written right here. Alrighty, make sure you take these notes, make them look pretty. Here's another one. One thing I'm noticing is that there's a representation of the graph. Maybe I'm being nitpicky, but the graph doesn't have a specific, this problem didn't tell you a specific point on the original graph. So the graph could be right here, or it could be right there. We just don't know. So you can't exactly claim that that's what it looks like, right? But that's not that important. Let's just do the problem. So if you look at when the graph is positive and negative, the graph seems to be positive at these regions. So we have negative infinity all the way up to negative 3. And then we have 1 to, this right here would be 1 to infinity with a union. You don't include endpoints because we don't know if these points, when derivatives equal 0, you cannot make a claim that it's positive or negative. And then when is it negative, it's like underneath, and that will be from negative 3 to 1. So when is the maximums and minimums? You just simply look at the change. When you have first a positive and then you have a negative derivative, that means something was increasing and then decreasing, that's maximum. Then when you go from a negative to a decreasing to a positive infinity, so increasing, that's a minimum. So that's how we get this minimum, and that's how we get that maximum. Alright, take your notes, make them look good. Find the intervals of increase and decrease of f of x and all the maximum minimums. Let's do this. Well, it's already been done. So let's go ahead and talk about it. I'm going to go ahead and use my highlighter because I got highlighting abilities. Alrighty, so we have x squared, which becomes 2x. Then we have negative 6x, which becomes negative 6. And that becomes 0. So the derivative equals negative 2x minus 6. Find the intervals of increasing and decreasing. So we want to know when the derivative equals 0, which ends up being 0 at 3. So what I like to do is I like to have a little, I actually don't do that. I usually do this in my mind at this point. But when I was a kid, I used to always do this, like this is 3. And then I plug in a number less than 3, like 0, that would be negative. And then I plug a number greater than 3, like infinity, and that would be positive. And then I would know that this is a minimum, right? I would know that this will be a minimum at that vertex. I actually knew that beforehand because this parabola has a positive in front of the x squared, which means it's facing upwards. But when a facing upwards parabola would have a minimum. And the minimum happens at whenever the derivative equals 0. So is that all we needed? Find the intervals of increasing and decreasing of f of x and all the maximum minimums. You have to make sure you include these things too. So please make sure that these are included in your notes. Let's continue. Find the derivatives using the power rule, then find the slope at the given point. Please do these problems. Pause the video and try them. So to talk about these, I kind of skipped a step. I don't need to really talk about 1 and 3. Those are kind of simple. The final answers would be, this one would be -8, -4. It's -1/2 like I wrote. This ends up being -8, 5, -5. And this one right here is going to end up being 1/4, 1/4. But the one I should probably talk about a little deeper is number 2 and number 4. I know that I've done problems like this in the past, but number 2, the way I did this, and the reason why this ended up having like a square on the denominator and a negative, is because I first looked at it like this: 2 times and then x plus 1 to the -1. Those are the same thing, right? The -1 exponent just brings it to the bottom, making this equivalent to this. So when you do the power rule, it's going to be -2 times x plus 1 to the -2 power, which x plus 1 to the -2 is brought to the denominator, which is why it's on the bottom down there. And since I had -2, that's why this negative exists. So I'm just letting you know that this is equivalent. I can't write. Sometimes this thing recognizes what I'm saying, and sometimes it doesn't. These two are equivalent. This and this is equivalent. Alrighty, let's move on to 4. 4, same way. I did x plus 3, and then I looked at it with a 1/2 power, because the square root means 1/2. So that ends up being 1/2 times x plus 3 to the -1/2 power. Since when you subtract 1 from 1/2, that would give you -1/2. And the -1/2 brings it to the bottom, which tells you why you have a radical on the denominator. Alright, let's move on. Alrighty, so please pause this video and figure out the answers for these. For each of these, find intervals of increasing, decreasing, and maximum minimums. So go ahead. So take that derivative. So the first one's very easy. We end up, when you plug in a 4, it's going to be 0, right? So this bad boy is 4. Plug in 0, that would give you a negative. Plug in infinity, that would give you positive. So we know when that's negative and positive. I'm going to write it down later to save time. For number 4, we are going to have to factor it a little bit. This is not enough. What can we factor out of all of these bad boys? Yes, a -3. Well done. So I did something that's not that smart. I first erased it and then tried to write down. Oh, I forgot my -3. -3. So first I erased all of it and then tried to write down the inside of the parentheses. And that didn't go so well, so I hope I did it right. I had to do the derivative in my mind and then factor out a 3. And I know how I am, but I'm sure you will fix that in your notes. So, and then the bottom needs to be factored further as well. Well, we're not done factoring this out, but I just like to do step by step. I like factoring out a -3, because when you do this, 3x. Because when you do this, life just looks a lot prettier. -2. Boom. Alrighty. So back to number 4. Can you factor this bad boy out? Yeah, x plus 1 and x plus 3. So let me just write it right there. -3, x plus 1, and x plus 3. Alrighty. So that would be -3 and positive 1. And that would be 0 and 2. And we're good to go. Okay, now we need to put our positive and negatives. Let me use a different color. Green is fine. So when I plug in negative infinity, then this will be, everything will be negative, right? So that would be negative. Because this will be negative, that would be negative, that would be negative. When I plug in 0, then this will be negative, that would be positive, and then that would be positive too. That's weird. Shouldn't have happened that way. When I plug in 0, 2 things become positive. Alright, well, let's trust the system for now. And then we plug in positive infinity, then we would have that's to be negative. Yeah, that's awkward. You know what? I just realized something. I'm just gonna not question myself. I'm gonna let you guys just correct me the next day if I made a mistake. Alrighty, so the next one, you plug in neg infinity, that's positive, it's gonna be positive actually, so let me go ahead and write that down. When you plug in neg infinity, that would be positive, and that'd be negative, so that'd be negative. And then that's, if you plug in 1, then that would be negative, and that would be negative, so that's positive. And then that's gonna be negative too. I'm not even gonna bother doing it. So, well, I should probably, I feel guilty now. Infinity would make that negative, and it would make that positive, and that's why it's negative. Alrighty, so now we found that. Do we need to do anything else? Yes, find maximum minimums. Okay, so we have a negative slope and then positive slope, that's minimum. We have a negative slope, then a positive slope. So at -3, that's a minimum, and then we have a positive slope and a positive, so that's a plateau. This is what a plateau would look like, by the way. This happens when you have like a positive and then a positive again, because it will never go down to become negative. And then over here we had a negative, then a positive, and then we had a positive and then a negative. So that would be a minimum at 0, and that would be a maximum at 2. Alrighty, again, rules apply to you. Make this look beautiful. Do not turn in something that looks as bad as what I produce. I'm just a teacher. You are the established, fantastic student. Alright? Do a good job. Alrighty, that's it.